Hello everybody, it's me, the periodic table of elements, and welcome to our show. Tonight we have here a special guest, but before introducing him, let me ask you a question: what do Amanita muscaria, beer, cereals and a ranch have in common? The answer is our guest, Vanadium.
Hi everyone. I'm very excited to be here.
Okay, let's get it started. So, Vanadium, you're an interesting element. Tell us something about you. Where do you live?
I am mainly in China, which managed to produce 54,000 tons of me in 2019. I also live in Russia, South Africa, Brazil and the United States, but to a lesser amount.
How can we obtain you?
I am extracted from petroleum after I had undergone an emulsion with the addition of water and magnesium nitrate. Later they elaborate me as happens in the extraction of iron minerals. Finally, I am recovered by reducing vanadium oxide with other metals.
How can you be useful to us?
I am mainly used for the production of low-alloy high-strength steel, which correspond to a type of steel that allows greater resistance to corrosion and better mechanical properties. I am also useful for the processing of special steels, special alloys and catalysts.
Do you like traveling? What trips do you usually make?
I like traveling a lot. As an example, did you know that considering the increasing popularity of the vanadium redox batteries, to which I give my name and where you can find me, in the last few years my demand has been growing, and it's estimated that it'll grow even more in 5 years. To give you an idea, some data from 2016 showed that about 77,000 tons of me are produced every year, and my European consumption, which is calculated adding production and import, and subtracting export, every year has to do with 12,700 tons.
So, since you're a critical raw material, how can you be recycled?
You might know that I am contained in different alloys used by metallurgical industry, and in different objects that have now been discarded by private companies because they have become obsolete. To recycle these alloys and objects, humans have founded specialized companies. These are based on an American patent which was released in 1981 and which is still available today. As I am a tough guy, the recycling process is quite complex and it implies several phases. First, the scrap is calcined with sodium carbonate and air to convert the refractory metals into molybdate, vanadate, tungstate and chromate ions and the base metals in water and soluble oxides. Afterwards, a leaching of the calcined material produces a dense solution, rich in refractory metals, which is treated with carbon monoxide or methanol, and then separated from the vanadium, molybdenum and tungsten salts. These salts are then subject to a new calcination, which results in the production of a mixed solid. This is, then, treated with water saturated with carbon dioxide or formic acid in order to selectively dissolve the vanadium salts, which finally are recovered by precipitation or extraction later on. Through this process humans are able to treat a large variety of different alloys, and this leads to a series of advantages. First, it doesn't involve high-energy pyrometallurgy, second, it minimizes the consumption of reagents, and finally it doesn't produce aqueous effluents.
And what about replacing you?
Theoretically, I could be replaced in all types of steel, but I have a really small amount of substitutes due to their limited performance in steel. 46% of me used in steel could be substituted by niobium, however this can't be considered a short-term solution due to the high effort involved in implementing the change. In the form of ferrovanadium, I can be partially substituted by ferroniobium. In some cases my replacement isn't possible, as with aerospace engineering applications. On the other hand, as a catalyst, I can be replaced with nickel and platinum in several chemical processes. In paints and varnishes, I can be replaced with titanium. I am also a fundamental component of redox flux batteries. However, some Swedish researchers have recently built a similar battery, which, instead of me, employs only organic elements to work. In particular, it works thanks to the conductive polymer and a solution of quinone. In addition, it has a higher energy density, which means that it is not only more environmentally friendly but also more efficient.
Such an amazing interview today with Vanadium, thank you so much. And that would be all for tonight. Stay tuned and don't miss out the next episode. Good night everybody.